pages 75 and 89. Let's go ahead and get started with a look at these problems. Let's start off with number 95. 95 says to write the area A of a circle as a function of its circumference C. So in other words, we want to have an equation that has A, then an equal sign, and over here on the right side, the only variable that we have is C. There can be numbers, there can be different terms, but the only variable will be C, area in terms of C. So what I've taught you guys to do is the first thing you want to do is write down the actual area formula of a circle, which is this. A equals pi r squared, okay? Now, right now, what do we have, students? We have area as a function of r, or in other words, area in terms of r. And that's not what we want. We want area in terms of C. So somehow we're going to have to get rid of this R and get a C in here somehow. So what we want to do is we want to find an equation over here that has an R in it and a C. An R and a C. Okay? And I'll show you why in just a minute. So this formula comes to mind. Circumference of a circle is pi d. Okay? Now, another way of writing circumference is this, and you guys should know this. There's two formulas you've learned down through the years when it comes to finding circumferences of circles. And that's the other formula right there, 2 pi r. Remember, guys, the diameter is always twice as big as the radius. So instead of putting d, I put 2r, which is the same thing as diameter. Remember, your diameter is twice as big as the radius. So here's here's an equation right here that has C and R. And that's exactly what I want. Because think about it, students. If I can take this equation here and get R all by itself, like R equals something over here, then I can pick that up and put it in for what over here? R. And then the R will be gone, and I'll have a C there instead. So I've got an equation here that has R and C. Let's get R by itself so I can make a substitution for R and get rid of the R. So if I get R by itself, here's what it looks like. I divided both sides by 2 pi. Okay? So I'm left with R equals C over 2 pi. Now I can pick this up and put it in for R over here. Okay? And that's really good because the R is gone now and I'm putting a C in place of it. Well, Mr. Error, what about the 2 pi? Guys, those aren't variables, those are numbers. 2's a number and pi's a number. So I'm totally good, okay? So where the R is, I'm going to substitute C over 2 pi. Now the squared, of course, goes on the outside of the parentheses. So next, I have to simplify this equation. So I'm going to square this fraction. When you square it, when you square C, you get C squared. When you square the 2, you get 4 because 2 times 2 is 4. When you square pi, you get pi squared. Now, I'm going to multiply these two together right here. I can put the pi over 1 and multiply top times top, bottom times bottom, okay? Now when I do that, that's what I'm going to get. Watch. My pi here cancels with my 2 pi's here. Leave me with 1 pi. 1 times c squared is c squared. 1 times 4 pi is 4 pi. So there it is. And students, look what you have. You have area in terms of C, or in other words, you have area as a function of C. Okay? Alright, let's try another one that's a lot more difficult. Let's try number 97. Write the area A of an equilateral triangle as a function of the sides S. In other words, you have an equilateral triangle. All the sides are congruent because it's equilateral, okay? All of the sides are congruent, and we're going to call those sides S, okay? And so we're going to write the area of the triangle as a function of S. Now I've taught you what to do. The first thing you do is you write your standard formula for area of a triangle, okay? So here it is, right there. Area equals 1/2 base times the height, okay? Now down here, I went ahead and drew an equilateral triangle so that I could see it, okay? And I think I'll make this a little bigger maybe. That's not going to work, okay? There we go. Alright, so I'm looking, this is my equilateral triangle, and I knew that somewhere I'm going to have to draw a height, so I drew the height right So somehow I'm going to have to think of a way to get some formulas over here that have an S and a B and an S and an H, or if I'm really lucky, an equation that has an S and a B and an H, all three. That's not going to happen, but it'd be nice if it would. So let's start off with a really easy basic one first, okay? Watch. If I told you to find the area of this triangle, you would take the base times the height and multiply it by what? 1/2. Let me say that again. That should make total sense to you guys. This is kind of middle school math. If you knew the base was 8 and the height was 8, you would take the 8 times the 8, base times the height, and multiply by 1/2. Correct? Sure you would. So Mr. Arrow, what are you trying to show us? Well, I'm trying to show you simply this. What do we call this side right here? S. But it's also the what? It's also the base. So in this triangle here, we can safely say that the length of the side equals the length of the what? Base. Do you see that okay? So with that in mind, I can make this comment here. So that means next, I can substitute S in for B. So I've gotten rid of one of my letters. That's really good, okay? So where the B is, I'm going to substitute S. So I'm halfway there. I got rid of the B and I have an S. Now the last thing I have to do is get rid of my H and get an S in there. So somehow I've got to get an equation over here that has an H and an S in it. Okay? Well, here's what I'm thinking. I'm thinking Pythagorean Theorem. Now you might not have thought of this on your own, but see if this makes sense. This right triangle right here is the exact same right triangle that you have right here. Okay? So S stays S, H stays H, and if this whole side is S, and you have an equilateral triangle, when you drop this down, it cuts the side right in half. So from here to here, this length here would be S divided by 2. You're cutting the whole side, which is S, in half. So I have this right here. Now guys, that's really helpful. Now I can set up Pythagorean's theorem. Remember, leg squared plus leg squared equals hypotenuse squared. Guys, I can set up Pythagorean's theorem, and the entire Pythagorean theorem will only have S's and H's in it, and that's really good. Here's what it would look like. Okay, I take my one leg here, I square it. I take my one leg here, I square it. I take my hypotenuse and I square it. Now, what do you want to get rid of? H. So what do you want to get all by itself over here? H. If you can get H all by itself, H equals something over here, then you can pick this up and put it in for H over here, and we're good. So our goal is to get H all by itself. So the first thing I'm going to do is pick up this fraction here, move it to the other side and make it negative. And I also went ahead and squared the fraction. If you square S, you get S squared. If you square 2, you get 4. Next, take the square root of both sides. So if you take the square root of H squared, you'll get H. If you take the square root of this side here, well, hold on a second. I think I'm getting ahead of myself. Before you would take the square root of both sides, it would be nice if we could go ahead and simplify this side over here. You see, students, the S squared is really over what? 1. So my one denominator is 1. My other denominator is 4. I need a common denominator. What's a common denominator for 1 and 4? Well, 4 is. So if I can multiply this fraction right here by 4, multiply the top by 4 and the bottom by 4, then I get 4s squared over 4. And if you were to reduce that, you would get what you started with, s squared over 1. But if you multiply the top and the bottom by 4, you now have common denominators, and you can put these two fractions together. So you would get this right here. Think about it. If you have 4s squared over 4, 4s squared minus 1s squared is 3s squared. Now all over 4, because 4 is your common denominator. Now take the square root of both sides. So when you take the square root of both sides, you get this right here. The square root of h squared is h. And you're like, whoa, Mr. Earhart, where'd this come from? Well, let me show you, okay? Please take some really good notes on this. We're going to take the square root of this side right here. So we have the square root of 3s squared over 4, correct? Now you learned in Algebra 2, whenever you have a radical over a fraction, you can split it up into the top and the bottom. So I have square root of 3s squared over the square root of 4, okay? Well, obviously, the denominator is going to be 2 because the square root of 4 is 2. Now here, now listen. listen to me carefully. If there was a positive sign here or a minus sign here, and you had two terms, you could not take the square root of s squared because you have two terms, but we have one term they're multiplying. So I can take the square root of s squared, which is s, and then leave the square root of 3 in the radical, or leave the 3 under the radical. So there we go. The square root of 4 is 2. The square root of s squared is s, and square root of 3 stays square root of 3. Now, why did I not put plus minus? Because lengths can never be negative. Lengths of sides of triangles can never be negative. So, there we go. This is what h equals. Now I can pick this up and put it in for h. Right here, okay? So that's exactly what I did. Here's my h, and I put this right here. Now, when I put this in, I noticed I had a fraction here and a fraction here, so I may as well make s a fraction too by putting s over 1. And now I can multiply top times top times top, bottom times bottom times bottom. 1 times s times square root of 3s would be square root of 3s squared. 2 times 1 times 2 is 4. Now where did I get this top right here? Watch carefully. 1 times s is s. S times s is s squared, and bring down your square root of 3. 2 times 1 times 2 is 4. So there we did it. We have area in terms of the side. That's pretty cool. In other words, all you have to do is tell me the length of this triangle, not the length. All you have to do. This is really cool, guys. Do you realize now, anytime you're given a equilateral triangle like this, if you know the length of the sides are 4, you can find the area. Put 4 in for s, square it, multiply it by the square root of 3, divide it by 4, and booyah, you have the area of the equilateral triangle. There's a lot of neat things, guys, mathematics can do for you, okay? Alright, moving on to number 101. A rectangular package to be sent by the USPS has the maximum allowed combined length and girth of 108. So that's the maximum length and girth you're allowed to have. Now, we know what length is. It's this right here. We got that. No problem. But what's length is how long the package is. But what's girth? Well, I'm glad you asked. Girth is the perimeter of the cross section. Okay, Mr. Earhart, what's the cross section? This right here is the perimeter around that small side right there. So when they say you have a combined length and girth of 108, that means you take the length, y, plus the perimeter of this, and you have the 108 inches, okay? That's what that means, okay? Alright, so moving on. Now that I've explained that, let's look at what they want us to do. Write the volume v of the package as a function of x. Excuse me. So we want our final answer to have a v, then an equal sign, then an x over here, okay? That's our goal. So think about this for a second. What I've taught you guys to do is always start off with a formula that you're familiar with. So how do you find the volume? This is called a rectangular prism. Hopefully you remember that from geometry, okay? This is a rectangular prism. How do you find the volume of it? You take the area of the base. Area of the base. By the way, that's what capital B stands for. Area of the base times the height. Now I have a question for you guys. If you were to lift this thing up and stand it on its end, it would rest on this side right here, correct? So when I say find the area of the base, I have a question for you. What is that base right there? Is it a circle, a square, a rectangle, a heptagon, hexagon, trapezoid, parallelogram? What is it? You say, well, Mr. Earhart, it might be a square. We're not sure if this side here is the same as this side here. Actually, you do know. If you look right up here, this side is labeled what? X, and this side is labeled what? X, which tells us that all four sides are congruent because we are accepting by just common sense that we have right angles here. So if we have right angles there, and this side here is X, and this side here is X, that means all of the sides are X, okay? So when I say find the area of the base, what is the base? It's a square, okay? So you find the area of the base right here. You find the area of the base, and then multiply it times the height. Now the height, of course, is y, okay? So let's go ahead and see if we can't simplify this formula a little bit and then go on from there, okay? So if they're asking us to find the area of the base, how do you find the area of a square? Well, you side, and that gives the area of the base. So for my b, I'm going to put x times x, right? That's the area of base, and x times x is x squared. So do you guys have any, hopefully this makes sense, okay? Not too difficult. Okay, I'll give you a second to get caught up in your notes there. Okay, now moving on. So what we have right now, guys, is we have volume in terms of x and h, or in other words, we have volume as a function of x and h. Now guys, x is good, because our goal is to write volume in terms of x, but this h has got to go, and we've got to get an x in there. So somehow we got to come up with a formula or an equation off to the side that has h and x, okay? So here's what I'm thinking. I'm going to start off first of all by doing this. I'm going to say, okay, they gave me, I know that, I know my total girth over here, I know my combined length and girth would be this. Remember, I showed you guys earlier at the start of this problem, girth is the perimeter. Well, how would you find the perimeter of this? If this side was 5, how would you find the perimeter? 5 plus 5 plus 5 plus 5. Well, if the side is x, how do you find the perimeter? X plus x plus x plus x. So x plus x plus x plus x. Then plus the length, which is y. So plus y. So that's what equals 108. Let's read it again, okay? Combined length and girth is 108. So x plus x plus x plus x plus y equals 108. So if you simplify this, you get 4x plus y. Well, Mr. Arrow, you're kind of not making any sense because we need to have an h over here somehow. You're exactly right. Now watch this. Let me ask you a question. Does, right here, do you see this y? Is that not also the same thing as your height? Over here, guys, listen to me. When I said find the volume of this, in order to find the volume of this, you would find the area of the base times the height. Well, the height is y. That's what it is. So h is the same thing as y. Okay, that's the height. Think about it. Remember, if you stand this thing up, so it's sitting on this side right here, and it's really tall up in the air, this would be the height right here. Okay, so y is the same thing as h. So see this y right here? I'm going to put an h in place of it. So now I have this. Now I'm cruising, guys. Now, what do I want to get rid of over here? H. So what do I want to get all by itself over here? H. So get h all by itself by moving the 4x over and making it negative. So 108 minus 4x equals h. So what can I put for h? 108 minus 4x. So, I got a clean page here, guys. For the h right here, I'm going to put this. So it looks like this. Here's the h, and I put 108 minus 4x. Now we're going to simplify this. Take the x squared and multiply it through, and you'll get this right here. So there, we did it, guys. We have volume. We have volume in terms of x, or volume as a function of x. So now all that I have to know is how long this side is right here. Let's pretend it's 3 inches. That's pretty small. Let's say 3 inches. All that I have to know is the side is 3 inches. I can take this formula here. Everywhere there's an x, put a 3. And just like that, we'll know the volume. That's pretty cool, okay? Now, unfortunately, we're not done. Okay? So here's what we have to do. We have to, next, we have to find the domain of the function. Now, domain deals with x, okay? So think about this. What in the world? Excuse me. What in the world could my domain be? Well, when you look at this function here, usually the first thing you say to yourself is, well, there's no fractions, there's no square roots, so x can be what? Anything. That's the first thing most students would say. But remember, we're dealing with a package, and there's certain things we have to remember. For example, what can x be or not be? Well, think about it. We know that 4x plus, now think about this, y or h, whatever you want to say, has to equal what? 108. Remember, we looked at that right back here. Right here, 4x plus y equals 108. Remember that? Why is that important? Because, guys, look, there's no way x can be, I don't know, 2,000. Because if you took 4 times 2,000, I don't care what y is, that'd be too big. It'd be way over 108. So there's some things that you got to realize that x just can't be, okay? It can't be. So I said to myself, okay, we know there's no way that y can be what? 0. There's no way. Absolutely not. Okay, so if y can't be 0, if it was 0, then there wouldn't be a package. You have to have a height. So I said, okay, y can't be 0, so I'm going to go ahead and put 0 in for y, just to see what x would be, just to give me kind of a boundary. So 4x plus 0 is 4x. Divide by 4 and you get 27, alright? So, if x is 27, then my y, or my height, is 0. That's not possible, okay? So I know then that my x has to be less than 27. Guys, listen to me. If your x is 27, or if you go greater than 27, 28, 29, y is just going to become negative. Y is going to be 0. If x is 27, if x is 28, y is going to be a negative number. If x is 29, y is going to be a negative number. There's no way y can be 0, and there's no way y can be a negative number. So your x, your domain is x has to be less than what number? 27. Now really, to be honest with you, it has to be greater than 0 also. That's common sense, but you really should include that. If you had just this on a test or quiz, I'll probably take off a little bit of points on that. So there you go, there's your domain. X is greater than 0 and less than 27. X has to be between these two numbers here. Alright, what else do they want us to do? Okay, use a graphing utility to graph your function. So, with your grapher, you would type this in, okay, right here. Now, if you do that, you've got to stop, guys, and use common sense, okay? Please, use common sense. If you type this into your grapher, listen to me. If you type this into your grapher, okay, and you hit graph, you're probably going to get no graph at all because you didn't fix your window. Think about your x values. Okay, first of all, let's all stop for a second. Everybody go ahead and type this into your grapher. Okay, take a second and type that into your grapher. Now, if your window right now is set as normal, standard C window, where it's positive 10, negative 10, positive 10, negative 10, if you hit graph, you're going to get hardly nothing. But look at your domain, your x window. You should fix your window for x to run from what two numbers? 0 to 27. So go to your window right now, push your window button, and make your x minimum 0. And I would make your x maximum 30, just to go past 27, just so you get a really good view of the graph, okay? So I would put 0 and 30 for your minimum and maximum x values. Now, Mr. Arrow, what do we put for our y values? Well, students, go to your table of values, okay? Go to your table of values and scroll to the 0, okay? Okay, so when x is 0, what is your y? 104. Do you see that? Look at your table of values. When x, your table of values should say 0, 104. So we're going to change our y window a lot. Just start scrolling down. 104. Now it's up to 3,000. I'm going to keep scrolling until I get to 27 on my x values. I'm up to 8,000, 11,000, 12,000. Nope, I got all the way up to 11,000. 600 was the highest value I saw. Okay, so when I went from 0 to 27, the highest x value that I saw was around 11,600. So I'm going to make it 12,000 so I have plenty of room. So for your y minimum, I would start at 0. I really would. I would start at 0. For your y max, I would make it 12,000. So go to your window, and for your y, make it 0 for the minimum, make it 12,000 for the max. Now hit graph, and you're going to get a really, really nice curve that looks like this. Well, I just have no drawing skills at all, but it kind of curves a little like this, then goes up, and then comes back. It comes down actually a lot faster on the right side, gradually, and then comes down a little steeper over here. Okay, so let's go back to what they ask us to do. Use the graphing utility to graph it. We did that. Now, what dimensions give you the maximum volume? So go back to your graph, students. Go back to your graph. Look, here's your graph. It looks something like this. Here's your coordinate plane. It starts here, comes up, and then comes down like this, okay? Well, your maximum point is right there. I've taught you how to find that ordered pair. how do you find maximums? Okay, go to your trace button. Look at the top right. Your second button from the right is trace. Hit second and then trace, and up will pop your calculations. Look at option number 4, maximum. So scroll down to number 4 and hit enter. Then your screen says left bound. Make sure you're over here somewhere on the left side of this point. Then hit enter. Then it says right bound, so move the cursor so you're over here on the right side of that point. You're telling the calculator you want to find a maximum. Then hit enter. You want to find a maximum between this point here where you scrolled over and this point here. And now it should say guess. Hit enter, and it will give you the ordered pair. There it is. At 18, you're going to get 11,664. There you go. So this is your x. Let's go back and look at your equation. Here's your equation. You're putting in numbers for x. You're getting out v's. So your coordinate plane is a v-axis and an x-axis. So you're putting x in and you're getting out a volume of this. So the question is, what dimensions will maximize the volume? Well, obviously, this is the maximum volume right here. What number gave you that maximum volume? 18. So you know that x has to be 18. Okay, let's go. Trying to find, well, this will work right here. We know that x has to be what? 18. So put 18 in for x, and then you know what your h has to be. So 108 minus 72. And that would be 36, I believe. So I hope that's right. So your height would have to be 36. Now remember, your height is the same thing as your y. So really you could say that your y has to be 36. So there you go. You got it. So your width is x. Your width has to be 18. Your length is y. And your length has to be 36. Or you can call it your height if you wanted to. Length or height. Okay. So there it is. When your package is 18 inches wide, 36 inches long, you will get the maximum volume of 11,664. This was a really, really good problem, okay? Good thinking problem. All right, let's continue on. The inventor of a new handheld video game estimates that the variable cost for producing the game is 95 cents per unit. Got it? 95 cents per unit. And the fixed costs are 6,000. So, he sells the game for $14.99. Let X be the number of games sold. Now, the total cost for a business is the sum of the variable cost and the fixed cost, okay? Excuse me. So, they want us to write the total cost as a function of games sold. Excuse me again, sorry. Now, students, that's just not hard to do if you think about it. They want a function that has c over here. Then over here, you want to have x because x stands for the number of games that are sold, okay? And we want a function, c is a function of number of games sold. So c is a function of x. And to be honest with you, that's pretty simple. Think about it. Their cost is how much per game? 95 cents, correct? So it says right here. The cost for producing the game is 95 cents per unit per game. So I'm going to take 0.95 times what? X. Because every game costs 95 cents. Then you have a fixed cost of 6,000. Maybe that's to buy equipment and to rent the warehouse, whatever. A fixed cost of 6,000. There, I did. I'm done. I think sometimes problems are so easy that students can't believe it's that easy, and they're thinking a lot deeper than they need to. That's it, guys. The cost is 0.95 times every game, X, plus 6,000. That's it. We're done with letter A. Well, letter B is just about as easy. Write the average cost per unit, C. Average cost per unit. Now, guys, please listen to me. If I told you our total cost was $20,000, got it? And I said that was for 100 games, I don't know, 100 games. How would you find the cost per game, the average cost? Well, you would divide the total cost by the number of games you sold, which in this case would be how many? 100. Does that make sense? If I said to you, yes, I know my total cost is $20,000, but what was my total cost per game? So how do I find the average cost? Divide it by how many games I produced. Well, Mr. Earhart, you don't know how many games that you produced. I know, but we gave that a name. Remember, X stands for the number of games. So I would divide by X. That's my number of games. So I took my total cost here and divided by my games, which is X games, and that would give me an average cost per game. It really would, guys. That should make sense, okay? Because you're taking your total cost and dividing it by how many games that you have, okay? Alright, moving on to 105. The force F in tons of water against the face of a dam is estimated by this function here, where y is the depth. So you give me a depth of the water, y, and I will tell you the force against the dam. Alright, well, the first thing that they want us to do is pretty elementary. They want us to simply fill in the table of values by putting 5 in for y, and then 10, then 20, excuse me for yawning, then 30 and 40. Now, I'm gonna do one of them for you, just to make sure you're with me, okay? So with your calculator, I would type in, we're gonna start with 5 right here, okay? I would type in 5 to the 5/2 power. So I would type in 5, arrow, then parentheses, 5 divided by 2, okay? And I would hit enter. Let me grab my calculator so I can do this with you. So, 5, arrow, parentheses, 5 divided by 2, that's 5 to the 5/2 power. Then hit enter, and you should get something like 55.90169944. Then take that and multiply it by square root of 10. So I would hit times, and when you hit times, this pops up on your calculator. Answer, and an asterisk, and then hit square root of 10. So hit your square root button, and then 10, and then close the parentheses. So you hit square root, this pops up, type in 10, close the parentheses, hit enter. You should get 176.7766953. And then, of course, all of these are being multiplied together. Then hit times 149.76, enter, and you'll get 26,474. Okay, 26,474. Now, students, I think you understand. I really don't want to go through and do all of those for you. That's really, in my opinion, kind of a waste of time. So I am very quickly turning to the back of my book, and you can feel free to do the same thing. I have no problem with this. Normally, I do not condone copying answers out of the back of the book, but here, as long as you know how to type those in, if you want to try a couple more and experiment, that's fine. As long as you know how to do that, I have no problem with you just quickly copying the values down in this situation here, okay? So this one here is going to be around, I'm rounding, this one here is going to be around 149,000. 20 is going to give you out around 847,000, I'm rounding. 30 is going to give you an output of about 2,300,000. So I'm going to put 2.3 million. 2.3 million. And then 40 is going to give you out approximately 4,700,000. So 4.7 million, okay? Close enough. There. So I filled in the table of values really easy. Now, use the table to approximate the depth at which the force is 1 million. Well, first of all, may I tell you something, students, please? You don't have to estimate it. You understand that. If they wanted the exact answer, you're looking for the force. Sorry, you're looking for the depth when the force is 1 million. So where the F of y is right here, you would put 1 million. You should be able to solve that, students. You really should at this point in your math career. This is a number, and the square root of 10 is a number. I would take 149.76 times the square root of 10, get that really big number, and then divide both sides by that number, so that y is all by itself. Okay? And so then what you would have is 1 million divided by that number. Would give you rounded 2,111.56 equals y to the 5/2. So, Mr. Earhart, how in the world do you solve that? Well, remember, guys, you would raise one side to the 2/5, and you would raise the other side to the 2/5. Okay, so 5/2 times 2/5, these would cancel, leaving you with y. And over here with your calculator, you would take this number here and hit arrow, and then parentheses, raise it to the 2/5 power. Okay, and if you do that correctly, you'll get 21.3 or 21.4. Now, I hope that made sense. That's not really, Mr. Eric, you just wasted a lot of time. Yeah, I did. But I want you to know on a test or a quiz, even though the directions here told you to estimate and not do that, I would expect you to know how to do that. That's old algebra 2. Solving equations that have a power like this to the 5/2 power. Now, having said that, this is the answer. When the depth is 21.4 feet, then you know that the force would be 1 million. But they want us to estimate. So the best way to estimate, guys, is this. Now listen to me. On your table of values, you saw that 20 gave you out 147,000 and 30 gave you out 2.3 million. So I would guess it's going to be in the lower 20s. I would have guessed 23 or 22. The answer is 21.4. But that's how you would estimate, okay? If 20 gives you out not quite a million and 30 gives you out 2.3 million, it's going to be toward the lower end of the lower 20s, okay? Now, how could you find a better estimate? Well, I just showed you here. You could do this, or you could have broken your table of values up into smaller numbers. You could have put in 20, then put in 21, then put in 22, then 23, 24. In other words, a better way to estimate would have been to use smaller increments of y up here, okay? Alright, hope that makes sense. If you're confused, maybe back it up and watch this again. Make sure you really understand this, alright? Okay, moving on to number 115. The cost of using a telephone calling card is $1.05 for the first minute and 38 cents for every minute after that. Now, a customer needs a model for the cost, say, of using a calling card. Which of the following models is the appropriate model? Well, guys, please don't make this harder than it is, please. And by the way, we are not going to take time and graph the model. I'm not going to do that, okay? Not going to do that. We might do this last part here. We'll see. Now, at first when you read this, it sounds kind of tough, but it's really simple. All that I did was this. I'm like, you know something? All that I have to do is, now listen to this, students, make up a scenario. I use the scenario 3.5 minutes, okay? And I don't have my paperwork in front of me. I don't know what happened to it. I think, let's just figure it out real quick. I said to myself, okay, self, how much, forget these models for a second, okay? Totally forget these. How much would it cost for me to make a 3.5 minute phone call? Well, the first minute's $1.05, so I know I'm going to pay $1.05. And remember, when you use 3.5 minutes, they always round that up. If you talked for 3 minutes and 1 second, they would round it up to 4 minutes. That's what it says, additional minute or portion. So I don't know if you know that. It's the same thing on cell phones or whatever. You're always rounded up to the next minute. So if you talk 1 second over 3, they're going to charge you for 4 minutes. So if you're going to talk 3.5 minutes, look at that as how many minutes really? 4. So the first minute's $1.05. So I'm left now with how many minutes? 3. 1 minute is $1.05. The 3 other minutes is 38 cents a piece. So 38 times 3 would be 24. Carry it to $1.14. So I have $1.05 for the first minute, $1.14 for the other 3 minutes. That's $2.19. Okay. So what I know is this. Are you ready? Now watch this. I know that if I talk for 3.5 minutes, I'm going to get charged how much? I just showed you. $2.90. So Mr. Earhart, where'd you get 3.5 minutes from? I just made that up. Because look, guys, do you not see how easy the problem just became? Now, I'm going to put 3.5 in for t right here. 3.5. And I'm going to simplify this whole thing. If I don't get out $2.19, then I know this model here is the right one. Okay? So, here we go. Where t is right here, I'm going to put 3.5. So let me get a different color. Cross this off. I'm going to put 3.5. Okay? So let's go ahead and simplify. I now have $1.05, watch carefully, plus 0.38. Then I have my greatest integer symbol. Hopefully you remember what those are. Greatest integer. I have 3.5 minus 1. That's 2.5. Okay? Now, greatest integer, think of a number line. Here's 2. Here's 3. Here's 2.5 right here. Greatest integer means you go to the left to the first greatest integer you come to. Okay, so if I put 2.5 into a greatest integer expression, it changes to a 2. You always go backwards to the left to the next integer. So I'm going to go backwards. So this 2.5 really becomes a 2. So now I have $1.05 plus 0.38 times what? 2. Well, guys, you can see right away it's not going to work. Remember down here I took 0.38 times 3. If you take $1.05 plus 0.38 times 2, you will not get $2.19. Now, to be safe though, let's check in the next problem too. So, right here where the t is, I'm going to put 3.5. That's how long I talked for, okay? So here we go. I'm going to put $1.05 minus 0.38, then your greatest integer symbol. And then inside there we have a negative sign, right here. And then 3.5 minus 1 is 2.5, so negative and then 2.5. Got it? Now watch this. Some of you are already thinking that negative 2.5 changes to a negative 2. No, it doesn't. Go to your number line, guys. Here's 0 over here. Here's negative 2. Here's negative 3. Right here's negative 2.5. What I said, always go to the left. So if I'm at negative 2.5, the next greatest integer to the left is negative 3. So now I have $1.05 minus 0.38 times negative 3. And guys, that works. A negative times a negative is a positive. Remember, you don't subtract first, you multiply first. So I have negative 0.38 times negative 3. Negative times a negative is a positive. We already know that 0.38 times 3 is 1.14. So it works perfectly. 105 plus 114 is 219. So this is the one I want to use right here. Now students, I guess real quick here, we can determine the call. The reason I really don't want to do this is on a test or a quiz. If I asked you guys to find the cost for 18 minutes and 45 seconds, I don't think there's one student, excuse me, in the room who's going to use this model right here. I know you guys, I wouldn't either. You would say, okay, 18 minutes and 45 seconds is really 19 minutes. The first minute's $1.05. My other 18 minutes is 38 cents. Multiply it together and go from there. So that's why I'm not wasting my time to do that, okay? It's not really necessary. But this is the proper model here, okay? This is a really good problem when it comes to teaching you to interpret and understand models, okay? Alright, here we go. Number 17, okay? The directions say to find the height of this rectangle in terms of x, okay? So I want the height in terms of x. Alright, now please watch this carefully. It's going to be a very confusing problem if you don't listen to me, okay? The first thing I'm going to do is I'm going to find this ordered pair right here. Now that ordered pair right there is called what? X, comma, y. Would you not agree with that? Sure you would. Look, if I go over x far, then I'm up y. Okay, I'm over x and I'm up y. Now this is going to be a tough problem, to the best I can to explain to students, but watch. So if I put x in, I'll get the total height from here all the way down to here. Okay, that should make sense. In other words, if I put in 1, what do I get out? 2. So I'm over 1 and I'm up how far? 2. So if I put this value in here, if I put this value in right here, then I'm up a certain height. Now, what is that value? I wish I knew. I mean, here's 1. This is 2. It looks like 2.2, but I don't know. So they're telling me this value right here is x. Okay? So instead of putting a number in for x, I'm going to put x in for x. Are you kidding? That's hilarious. I'm putting x in for x. Well, guys, if you put x in for x, nothing changes. So now I know the whole height all the way up this whole green line right here. If I put x in for x, it's just this. Do you see that? So the whole height from here all the way to here is just this. So far I have this. Now, does it help me find the length of the rectangle, does it? Maybe it does, guys. Hold it, I just had a thought, and I don't have many of those. What's the height from here to here, the red line? We don't know. Yeah, we do. How far up is this point right here? 2. How far up is this point here? 2. So I know the red height is 2. So if the whole height is this, and this much is 2, subtract the 2. Think about it, guys. If this whole green line was 10, pretend it was 10, and this red line was 8, 10 minus, or this red line was 2, 10 minus 2 is 8. This little line right here, this green line right here, would have to be 8. So I'm going to take my whole distance from here to here, my whole green distance, which is this, minus this distance here, minus 2, and that'll be the height in terms of x. So simplify it and you're done. Not too bad, guys. There it is. So your height of the rectangle equals that right there. That's pretty cool. All right, number 119. All right. Now this one's pretty interesting, guys. Think this through. We have two graphs. We have a curved graph like this. And the model or the equation for that curved graph is this right here. We have a linear graph right here, a straight line. Okay? And that line is modeled, or you get that line from this equation, this model right there. So let's take our time and think this through here, guys. Look, I want to find the height of this rectangle. The height of it, okay? So I'm thinking, look, first of all, I can very easily, now think about this, I can very easily find the height from here all the way up to this here, okay? It's very easy. You should know how to do that. If I put a value into this function here, if I'm over so far, and I put that value in for x, it will tell me how high I am, okay? So, what am I putting in for my value right here? I'm going over how far? I'm going over x. So I'm going up this far, okay? So what am I putting into this equation right here? X. Well, guys, once again, if you're putting x into this equation, you're going to get out 4x minus x squared. So the total height from here all the way down is, I'm going to copy that line right over here if at all possible. I don't think I'm explaining this very well. This whole line right here, from here to there, is 4x minus x squared. Because I could put x in, that's what I got out. Now if they would have said to put y in, then I'd put a y in for x. Okay, and I'd get out a different expression. Now, think about this, guys, look. Didn't want to do that, hold on a second. Sorry, guys. Alright, now let's take a look at this. I just found the total height from here all the way to here. I can also find the height from here to here. Think about it. If I put in a value in for x to this equation here, I'm over x and I'm up a y amount right there. So using this equation, what am I going to put in for x? X again. So now the length from here to here is just 2x. Because I'm putting x in for 2x, so I get out 2x. So now, that's not the one I wanted. So now I know this whole length from here to here is just what? 2x. So guys, how would I find this little length from here to here? In other words, how would I find the length from here up to here? Well, the whole length the whole length is 4x minus x squared. This much is 2x. If I take the whole length, this, and subtract out this, I'm left with a little amount right here. So 4x minus x squared minus 2x. You have like terms here and here. 4x minus 2x is 2x. There you go. That is the height of that rectangle in terms of x. Tough problem, but a really good problem. Alright, 121. Now we're going to find, according to the directions, we're going to find the length in terms of y. The length in terms of y. So students, distance, here we go, the length in terms of y. So let's think about this. First of all, I have this curve right here, okay? And that curve is given to me by this equation right here, that model right there, okay? So I'm thinking, look, now we're doing it backwards. Think about it, guys. If I'm up so far, y, then I'm over so far also, okay? So I can come up here, think about it, I can go up and put a y value in, and if I put a y value in, it's going to tell me exactly how far over I am. There's no more work, that's it. I mean, look, guys, look at this, I'm up how much? Y. So then put y in for y. I'm up y, so put y in for y, and then I'll see how far over I am x-wise, okay, to this ordered pair right here, x comma y. So if I put a y in and simplify, what does x equal? 1/2 y squared. So there you go, you got it. The length of this rectangle is 1/2 y squared. Now guys, that's pretty simple, it really is. Okay, alright, 123. Okay, we want to find the length of this rectangle. Alright, so look at this carefully. First of all, I know for a fact that I can easily find the length from here over to this point right here. Okay, and I think it's hard to see, but this, I guess I need to look at my book here real quick. Give me just a second here. I think it's page 89. There's a little glare and I can't see very well. Alright, 89, 90, let's see. Okay, this is a 2 here. Alright, wasn't sure what that was. This is a 3. Alright, now, so look guys, I know I'm up how far? Y. So if I put y in, I will get the distance from here to here, okay, which is my x. Alright, on this graph right here, that curve goes to this model right here. So, this is my x distance, put a y in, and I'll get out my x from my x comma y, okay? So, put y into the equation, okay? Put y in, which obviously is going to give the same thing out. Put y in for y, and you get y squared, okay? So, the distance, now come on guys, watch this, okay? The distance from here to here is going to be y squared, alright? From here to here. Now students, I've got a question for you. What's the distance in red from here all the way across to here? We don't know, Mr. Yeah, you do, guys. From here to here is the same thing as from here to here. You're assuming you have a right angle here. So the distance across the bottom here is 4. So the whole distance across is 4. So 4 goes all the way from here to here. So we know we have the answer, guys. If the whole distance is 4 and this much is y squared, you take the whole distance 4, subtract out y squared, and you're left with the distance of the rectangle, the length of the rectangle from here to here. So the length of the rectangle is the whole distance 4 minus this here. And there you go. These were not easy, guys, okay? These are tough. A lot of these are tough, and I warned you they would be. Study, study, study. Work hard on these. I hope this homework video has been a help to you. If you have any questions, don't hesitate.